Download this code from codegive.com, link in the description below. Troubleshooting can no longer create a context with specific ciphers 1462 in GitHub Actions. The can no longer create a context with specific ciphers 1462 error in GitHub Actions usually indicates an incompatibility between the ciphers supported by your workflow's environment, specifically, the runner machine, and the ciphers requested by a tool or application you're using within that workflow. This often arises when trying to establish secure connections, example HTTPS, using outdated or explicitly disabled ciphers. Let's break down this error, its causes, diagnosis, and various solution strategies with examples. Understanding the error message and context. Asterisk can no longer create a context with specific ciphers 1462. This is a generic error thrown by the underlying security library, typically openssl or similar, indicating it can't establish a secure context, example for TLS/SSL, using the requested ciphers. The 1462 is often an internal error code that might not be directly helpful without more context. Asterisk GitHub Actions runners. Asterisk GitHub Actions workflows run on virtual machines provided by GitHub. These runners have a pre-configured operating system, Ubuntu, Windows, Mac OS, and a set of pre-installed tools. The security configuration of these runners can evolve, and older ciphers might be disabled for security reasons. Asterisk cipher suites. Asterisk a cipher suite is a combination of cryptographic algorithms used to establish a secure connection. It specifies the encryption algorithm, key exchange algorithm, and message authentication code, MAC, that will be used. When establishing an HTTPS connection, the client and server negotiate a mutually supported cipher suite. Asterisk older software / configurations. Asterisk the most common cause of this error is using older software, example older versions of UGIT, curl, Python libraries, or having a configuration that explicitly requests outdated or disabled ciphers. This also applies to software needing connections to older, or insecurely configured, remote servers. Common causes. 1. Outdated dependencies or software. Asterisk older versions of libraries like openssl, curl, UGIT, Python's requests module, or Java's SSL libraries might be configured to use outdated cipher suites that are no longer enabled by default on modern systems. 2. Explicitly requesting insecure ciphers. Asterisk sometimes, configuration files or command line arguments explicitly request specific cipher suites. If these cipher suites are disabled on the GitHub Actions runner, you'll encounter the error. This is often done in older projects or when trying to connect to legacy systems. 3. Server-side configuration issues. Asterisk the remote server you are trying to connect to might be configured to only offer outdated cipher suites. While less common in interactions with major web services, this is a possibility with private or legacy servers. 4. Operating system security policies. Asterisk the operating system on the GitHub Actions runner, example Ubuntu, might have security policies that disable certain cipher suites at the system level. 5. Java SSL/TLS issues. Asterisk if your workflow involves Java, the Java Virtual Machines, JVM, default SSL/TLS configuration might be outdated or incompatible. Java has its own way of managing cipher suites through java.security configuration files. Diagnosing the issue. 1. Examine the error message and logs. Asterisk carefully inspect the full error message in your GitHub Actions workflow logs. The message might provide clues about the specific cipher or protocol that's causing the issue. Look for stack traces or verbose output that pinpoints the failing library or command. To identify the offending command /code *, determine which specific command, script, or code block is triggering the error. Is it a curl command, a Python script using requests, a Java program, or something else? 3. Test locally. If possible, try to reproduce the error on your local development machine. This can help you isolate the problem and experiment with solutions before deploying them to GitHub Actions. Make sure your local environment closely matches the environment of the GitHub Actions runner. Consider using Docker to mimic the runner environment. 4. Enable debugging /verbose output *. Most tools and libraries offer debugging options that provide more detailed information about the SSL/TLS negotiation process. For example, *curl * use the v or -verbose flag to see detailed information about the connection attempt. *git * use the d or -debug flag. Python's requests * enable logging using the logging module and configure it to capture erlib3 logs, which requests uses under the hood. This verbose output will often show you which cipher suites are being offered by the client and which are supported by the server. You can then compare these lists to see if there's a mismatch. 5. Check the supported ciphers *. You can use tools like openssl to list the supported cipher suites on the GitHub Actions runner. Add a step to your workflow that executes the following. This command will print a list of all cipher suites supported by openssl, along with their properties, example key exchange algorithm, encryption algorithm. Compare this list to the cipher suites that are being requested by your application. Solution strategies. Here are several strategies to address the can no longer create a context with specific ciphers 1462 error, ordered from the most recommended to the less desirable, but sometimes necessary, options. 1. Update dependencies /software *. This is the preferred solution. Update the libraries and tools that are causing the issue to the latest versions. Modern versions typically use secure and widely supported cipher suites by default. Python, using pip. Node.js, using npm or yarn. Java, using Maven or Gradle. Make sure your pom.xml or build.gradle files specify reasonably recent versions of your dependencies, especially any SSL/TLS related libraries. Often, upgrading the JDK version itself will bring in newer SSL/TLS implementations. System packages, using apt on Ubuntu, yum on CentOS/RHEL. To configure the tool to use modern ciphers *. If updating the software isn't possible, try to configure the tool to use more modern cipher suites. This often involves setting environment variables or command line options. *curl * use the -ciphers option to specify a list of allowed cipher suites. The value default at @SIC level equals 2 is often a good starting point. It uses the OpenSSL defaults with a reasonable security level. You can also use more specific cipher suite names, example TLSV 1.3 plus CHA-20, EC RSAAES 128 GCM SHA-256, but it's generally better to rely on the default setting unless you have a specific reason to use a particular cipher. Be careful when specifying cipher suites explicitly, as you might inadvertently disable important security features. *git * use the -ciphers option, similar to curl. Python's requests *. The requests library typically uses the system's default SSL/TLS configuration. You can influence this indirectly by setting environment variables that affect OpenSSL or by using a custom adapter with erlib3, the underlying library. Java * you can configure the cipher suites used by the JVM through the java.security file or by setting system properties. The specific approach depends on the Java framework you are using. You can modify the java.security file, usually located in $java_home/conf/security/java.security or $java_home/jre/lib/security/java.security, to configure SSL/TLS settings globally for the JVM. However, modifying this file can have unintended consequences, so proceed with caution and create a backup first. Look for lines that start with jdk.tls.disabled algorithms to see if any cipher suites are explicitly disabled. You can comment them out, after careful consideration, to re-enable them, but this is generally not recommended. 3. Enable legacy protocols. Use with extreme caution. This is generally not recommended because it can weaken the security of your workflow. Only resort to this if you absolutely must connect to a very old or misconfigured server, and you understand the security implications. *OpenSSL*. If you're using OpenSSL directly, you might be able to enable legacy protocols by setting the openssl_conf environment variable to a custom configuration file that allows them. However, this is a risky approach. *Java*. You might be able to enable older TLS versions, example TLS 1.0, TLS 1.1, by modifying the jdk.tls.disabled algorithms property in the java.security file. This is highly discouraged unless you have a very specific and compelling reason. 4. Address server-side configuration issues. If applicable, if you control the server you are connecting to, the best solution is to update the server's SSL/TLS configuration to support modern cipher suites. This is the most secure and sustainable approach. Use tools like testslow.sh to analyze the server's configuration and identify any weaknesses. 5. Docker containers. Consider running your workflow inside a Docker container that has the necessary dependencies and configurations. This can provide a more isolated and predictable environment. However, you still need to address the underlying cipher suite issue within the container. Specific examples in GitHub Actions. Here's an example of a GitHub Actions workflow that updates dependencies, uses curl with modern ciphers, and lists the supported OpenSSL ciphers. Important considerations. Security best practices. Always prioritize security. Avoid enabling legacy protocols or insecure cipher suites unless absolutely necessary. Documentation. Refer to the documentation for the specific tools and libraries you are using to understand how to configure SSL/TLS settings. Testing. Thoroughly test your workflow after making any changes to ensure that it works as expected and doesn't introduce any security vulnerabilities. GitHub Actions Runner updates. GitHub Actions runners are updated periodically. Be aware that changes to the runner environment might affect your workflow. Regularly review your workflow configurations and dependencies. Server compatibility. Ultimately, the cipher suite negotiation depends on both the client, your workflow, and the server. If the server only supports outdated cipher suites, you might be limited in what you can do. In that case, advocating for server-side updates is the best long-term solution. Debugging checklist. 1. Review the full error message. Capture the complete error message, including any stack traces or verbose output. 2. Identify the offending code/command. Pinpoint the specific code or command that triggers the error. 3. List OpenSSL ciphers on the runner. Use openssl ciphers v to see which ciphers are supported. 4. Check for explicit cipher configuration. Look for any explicit cipher suite settings in your configuration files or command line arguments. 5. Update dependencies. Upgrade your libraries and tools to the latest versions. 6. Test with modern ciphers *. Try using the -ciphers default @sic level equals 2 option with curl or OGIT. 7. Examine server configuration *. If you control the server, use tools like testslow.sh to analyze its SSL/TLS configuration. 8. Consider Docker *. Run your workflow in a Docker container to isolate the environment. 9. Document changes *. Keep track of any changes you make to your workflow or configuration files. By systematically following these steps, you should be able to diagnose and resolve the can no longer create a context with specific ciphers 1462 error in your GitHub Actions workflows. Remember to prioritize security and always update your dependencies to the latest versions.